31. So we're multiplying here, right? Ash, is this the one you said you had issues with, all this multiplying stuff?
No, the 33's dividing, the multiplying seems a little easier.
And really, the dividing, if that was a division symbol, it's the same thing. You just got to flip things. It's basically the idea behind division. So if we can do this, then we can do number 33. So let's make sure we got this down. So you can multiply all the top and multiply the bottom and come out here to the end and get an answer. But the idea is that if you can, look and see anything on the top of one fraction that matches up with the bottom on the other fraction, they'll cancel. And you might say, well, this is 4 minus m. That's m minus 4. That's the same thing, but it's not. There's a negative on the m, and there's not down here. There's a minus on the 4, but there's not up here. So what you do is you factor out a negative 1 is what you're going to do. I guess I shouldn't write like that. So I'm going to factor out a negative 1, which makes the m value positive. It makes the 4 negative. So the trick is I can rewrite these things. I can switch signs if I distribute a negative 1. Does that make sense? So for instance, if I said 3 plus x, I could rewrite that as negative x minus 3 if I distribute a negative 1 in the front of it. I can factor out these two things are the same because a negative 1 times a negative x is a positive x. And a negative 1 times a negative 3 is a positive 3. And I wrote them in different order.
Are you getting the negative 1 off the end?
Yeah, I'm factoring out a negative 1. So when I do that, I've got m minus 4 and m minus 4, and they cancel. So I'm left with 7 over 2 times negative 1 over 6. Which would be negative 7 over 12. So the trick to those is that you can switch everything if you factor out a negative 1. If you put a negative 1 in front of it and you distribute it, you'd wind up with what you had to begin with. Well, that's freaky looking. I'm shaking this pen back and forth. And it's like, wow. I'm sorry. Okay. So 32 is a division problem. Hold up. Wait a second.
That negative 1, why is it still there?
Well, when I cancel things, technically, it's like it turns into 1. It doesn't like it disappears. It doesn't turn into 0. It turns into 1. And if there's anything in front of it, it stays there. It's like negative 1 times 1 is a negative 1.
Well, see, I thought we were timesing that negative 1 by m and then timesing the negative 1 by...
Okay.
But we're not. We're factoring out of it. That's why it's right.
Right. So let's play what if. I'm gonna change colors and play what if here. Okay. If it was 7 over 2 times m minus 4, so that was original. Let's say that's still original. But over here it says times, and it was m minus 4 over 6. So the reason why I'm changing this is I'm changing it from the original problem said 4 minus m. So I'm m minus 4 now. Okay. Now when I cancel that, because it's the same thing, it's not like it just poof, there's nothing there now. It's really like saying m minus 4 divided by m minus 4. That's really what I've done. And if it's the same thing on top and bottom, it's like saying 1 over 1. So it's like they turn into 1s. So when I cancel this, there's like a 1 there, there's like a 1 here. Well, you didn't have much problem seeing 2 times 1 is 2, right? So there's a 2 on the bottom, right? I mean, I don't think that was the question, right? We didn't care about that, the 7 over 2.
Yeah.
We cared about why is that still negative 1 there. Well, because I had to fool around to make it to where I could cancel it, had to fool around and make a negative 1 in the front. So if there's a negative 1 in the front like up here, just like there's a 2 in the front down there, you got to treat them the same way. There's no racism in mathematics. There's no discrimination in mathematics. I don't know, that was stupid for me to say. But that's the idea. Because there was a negative 1 in front. So negative 1 times 1 is a negative 1 still. So the negative 1's still there. If you ever have crap that's in front, it stays there. I shouldn't say crap, but at this point in the semester, that's probably the way you all feel. So, I'll just speak within your vernacular. I don't even know if those are real words. My goodness, what's wrong with me? You want to go ahead and say divided by? Well, here's what the problem says here. At least I'll go. This is 32. And if it's a division, you take the second guy here and you flip it. Take the second one, you flip it. So it's like saying x squared minus 25 over 12 times 4 over x plus 5 squared. Okay? Do you want me to go into the detail of why that is, or do you just want to take it as facts? It's the facts. If you divide by any fraction, you multiply by its reciprocal. That's the little property we're using. So we're going to multiply by its reciprocal, which is this. Well, okay, this is x plus 5 times x plus 5, right? There's two x plus 5s. Now the top can be factored. You always want to try to factor these out as much as possible. Yeah, that's right, x plus 5, x minus 5. So we can rewrite these like that. Okay, is it alright if I scratch this out because I've rewritten it? And scratch this out because I've rewritten it? Okay, so now I've got x plus 5 up here on the top in the numerator, and I've got 1 x plus 5 in the denominator, and I can cancel that. Yeah, now you can fool with 4 and 12, right? 4 goes into 12 3 times, and 4 goes into itself once. So now what you're left with is 1 times x minus 5, which is x minus 5, and 3 times x plus 5. And I'll just leave it like that, I suppose. Now I don't know if we went around and about on that last one. You think, well, why didn't we factor out a negative to make this match up, right? Because it's negative 5, positive 5. The difference is that these x values are both positive. If you pulled out a negative 1, if you did that whole negative 1 deal that I did just a second ago, well, that would be like saying negative x minus 5. Well, this is a positive x minus 5, so there's no point in trying to do that negative trick I did a second ago. So there's no point in doing that. Both of these terms in the binomial, both these things right here would be exactly the opposite sign as these two. If it's x plus 5, it would be negative x minus 5. They have to be the completely opposite. So that's why you don't have to do that like in the last example. So we're going to do 33 now. Does that shed a little bit of light on number 33? I'm not going to rewrite. It has a division in it. Number 33 is a division problem. I know you can't see it back there. So it's a divide. So I'm going to take the top and put it in the bottom, and the bottom put it in the top. I'm going to flip it. So I'm not going to write the divided by part, because that's one more place for me to screw up. So make the numerator the denominator, and the denominator the numerator. Flip that bad boy. Okay, so you want to do the hard part first? So you always try to factor as much as you can out, because it'll usually cancel. Now, since this is the question is this, and this is the question they give you, and they want you to foster your little abilities of factoring, basically. So it'd be pretty stupid of them to make a problem up and put an n plus 2 on the bottom and it not cancel up here. It'd be pretty just stupid of the person that made this problem up. I'm not putting past it, okay? It could be just a stupid problem. But I bet that this is on top here. So here's what I'm going to do. I'm going to use my contextual clue of n plus 2. I don't know if it's going to work, but I'm just going to set that to be that and figure out what would I have to be on the other ones here. What would the other one have to be if it was n plus 2? You'd have to have a 4n, right? And you'd have to make a 6. So that would need a 3, and it'd have to be a negative 3, wouldn't it? So I'm using that. You can factor that out if you want to, all by your lonesome. But I'm telling you, it's a little bit easier to look here and see if it doesn't work in here.
What does it say?
Which one?
What did you factor out?
I got m plus 2 in parentheses and 4m minus 3.
But negative 3m plus 2m doesn't usually divide it, right?
See, m, that'd be a 4, that'd be a negative 3, but that'd be a positive 8.
I would get to it.
That 4, yeah. I know what you mean. You get so wrapped up in just putting them together. It's that, I hate it when they put a number up in the front. That's what I always don't like. I don't like those. But it should work out. So now I've rewritten this, so I'm going to mark that off if that's all right. And now my m plus 2 and my m plus 2 would cancel. My m and the m on that 3m would cancel. And I'm just left with 3 times 4m minus 3 over n. That's all we're left with. And that's multiplying and dividing. I mean, if you can do those, you can do all of them. Those are the toughest ones on there, I think. That's just my opinion, though.